Very good evening to one and all gathered here. So I welcome you all back for the next today's session on mechanics of solids. So in this session, we are going to discuss about the very fundamental, basic the parameters in mechanics of solids. So let us see the learning objective of today's session. Why we want to undergo study on mechanics of solids from the student-centric point of view. Point number one, which clearly describes about the basic knowledge on stress strain calculation subject to different types of loading conditions, say tensile, compression, etc. The next point number two, which clearly tells about the physical illustration graph, say shear force bending moment diagram on various types of beams like cantilever, simply supported beams subject to different types of loads like point load and UDL, uniform distributed load. Then the next third point, which clearly describes about an engineering student, okay, he might be civil or mechanical, they must have the tendency to design different type of solid structures that are used in buildings by careful selection of material and also proper definition of geometry. The next last learning objective from the student's point of view. So the student member, they can able to learn by comparing the different strength of material with respect to the internal stress and strain, which is greatly influenced upon it. Say for example, so the strength of material for steel, for rubber, that may vary. Okay, so they can able to compare and analyze the study accordingly. So these are the different learning objectives. Before moving to the session, just I have presented for your kind reference. Now let us straight away go to the simple stress strain, the basic fundamentals in mechanics of solids. So here some of the graphical physical illustrations that has been presented here in before you. So let us start with the stress. What is meant by a stress, physically called as. So here, the simple empirical equation, the model which is given here, stress is the ratio between the force and the given cross-sectional area of the object. Let us take F is the force which is applied on both the end of the object. You take a cylindrical mild steel rod which is subject to tensile force at both the end. Equal amount of load is acting at two opponent end at a specific the force. Now A naught is the area cross section. Now the stress is acting at a particular area on the given material that is defined by A naught. So this can be defined as sigma is equal to F by A naught. So what is stress? The next slide is defined as an expression, physical expression that can be taken as a ratio of applied force by resisting area due to the external load based on the material. Now let us see strain, importance of strain deformation in solid material. Let us take the picture 1 and next one picture number 2. First let us go with picture number 1. So initially you take a rectangular block. This is the original shape of the material. Apply compressive load. Okay, so compress the given rectangular block with the help of the manual load. Okay, keep your palm very tightly on the given object surface and tightly press it, compress it. So see here, we can able to experience the change in geometrical shape. So it has been converted into parallelogram shape from rectangle block to parallelogram shape. This is due to the phenomenon of the shear stress. So the shear stress is the angular deformation that allow the material to deform angular direction. So simply called as what is simply called as strain. So if you apply any load on the given material, it will change up with respect to the original volume. So simply mathematically defined as original length by change in length, strain. It is a dimensionless constant, no unit for that. The next one, let us see about what are the different classification of stresses. So these things we will be solving in the problem. So let us have a clear-cut the parameter definition for each type and the classification of stresses. First one, compressive stress. So two equal and opposite force which is placed in inward direction on both the end of the material. So the resultant phenomenon that experiences a compression stress on the given solid material. What is tension? Tension is nothing but the force which is acting outward direction. Whereas in compression, what is the difference? The two equal opposite force is placed towards the inside direction, facing towards the inside direction. So this is the difference between tensile and compression stress. Tension means elongation. The material will stretch like a thin wire, whereas in compression, reduction in the length of the material takes place. So tension means pulling force is mainly influenced. Compression, pushing force. If you want to clearly understand what is the difference between the relationship between tensile and compression, then keep it this way. It would be very easy for you. And further, we will proceed with the classification of stress, shear stress, the third type. So here, what is shear stress? As I told you, partial information, compression stress. So shear stress is nothing but slight angular variation due to the physical deformation of the material experienced by it based on the external force which influence much greater amount. So due to that, the material began to break and cross-slide by having relative motion with each other. You can see the diagram here. So when we apply a tensile stress, after reaching the particular ultimate point, the material becomes weaker, so it will undergo shear stress by producing a fracture. So the fracture takes place by breaking the metal by sliding relative to each other. Now let us discuss about different types of strain. So first one is linear strain. What is linear strain? So this kind of deformation takes place along x-axis, horizontal direction. So this can be physically represented as the ratio between the change in dimension of the body due to the deformation with respect to the original dimension. What is lateral strain? So we know linear strain, that is the strain deformation takes place along x direction, whereas in lateral strain the deformation of the material subject to 90-degree normal perpendicular to linear strain. So this deformation occurs at perpendicular to the linear strain. Then next one is shear strain. So the shear strain which leads to the shear deformation acting on the material. So this is also a kind of physical deformation which allows the shape of the object to get changed. and this is physically represented by the symbol gamma. And last one is volumetric strain. What is volumetric strain? You take a rectangular block, okay, which has three dimensions: length, breadth, and depth. Okay, so how to define the original volume, the dimension of a rectangular block? V is equal to LVD. Okay, now this is the size of the original dimension. So here, when we apply a force on every three direction with respect to x, y, and z coordinate, so the size of the object began to change in all three directions. Say change in length, change in height, also change in width. So that is what here by equation they have expressed here. Delta V, change in volume due to the external force, that is equal to, here length will change with respect to x-axis, whereas other two will be maintained constant. Depth, the breadth. Here next one, breadth will change, whereas length and depth will remain constant. Whereas the other combination, depth of the object will get changed due to deformation, length and the breadth will be as such constant. Okay, so volumetric strain is nothing but delta V by change in volume by original volume. That's all. So this can be simply referred as E suffix V, volumetric strain is equal to Ex plus Ey plus Ez. That is the strain deformation occurring in all three different coordinate axis directions. So that is expressed here by means of set of equations. Then modulus concept. Now we are going to see three different modulus concept in mechanics of solids. First of all, what do you mean by a modulus? Modulus is nothing but defining the physical elasticity of the material, okay, due to the force which is greatly influenced on it. So now let us see the three different types of modulus. So modulus of elasticity, that is Young's modulus, which defines the stiffness of the object, which is used to refer the stiffness of the object. So simply I can define linear stress by linear strain. Simply say sigma by E. Okay. And here there are the property, the material tables are given. The Young's modulus property for aluminum, bronze, brass, and copper are tabulated here. This is for your kind reference. Next one, modulus of rigidity. This is denoted by the letter G, and it is taken as a relationship between shear stress and shear strain. So shear stress is nothing but tau, shear strain pi. So as I told you that the modulus of rigidity, so the deformation due to shear modulus or shear stress based on the external force F, which is influenced on the object. Last one is a bulk modulus. So this is defined by the letter K. So bulk modulus is the relationship between volumetric stress by volumetric strain. So you take a sphere, a ball. So if I want to measure the volume, the bulk modulus of that sphere, apply pressure on all the directions surrounded by the sphere and just sense whether the deformation, if it is within the elastic limit, will regain its original shape or otherwise will not come back to the original shape. So the bulk modulus can be applied to solid or fluid by using a pressure by allowing them to act on all the surface of the object. So now we shall discuss about the physical relationship between the different modulus that we have seen in the previous slide and the Poisson ratio, that is mu. First, let us discuss about the relationship between Young's modulus and the bulk modulus. So this is defined by the equation E is equal to 3K within bracket 1 minus 2 into mu. Next one, defining the relationship between Young's modulus and the rigidity modulus. E is equal to 2 into G within bracket 1 plus 2 mu. So these equations we will be using when we are solving the numerical problems. Next one, we are going to see about Hooke's law. So how to define ultimately the theory of elasticity using Hooke's law. Robert Hooke, the name of the scientist, so he has defined this principle by considering a set of helical coil spring. Okay, so by allowing the spring to deform due to the applied load, so what is the amount of displacement depending on the given load? So that is the main ideology measuring the elastic behavior of the spring. So this can be defined, applied stress is directly proportional to the strain. Sigma is directly proportional to strain. To remove the proportionality constant, we can use K. So with this lecture, I conclude that in today's class, we saw the basic fundamentals of mechanics of solids by treating different type of stresses and strains as an overall comparison. Then we saw about different types of modulus elastic constant, that is modulus of rigidity, modulus of Young's modulus, bulk modulus, etc. So in the next subsequent class, we will see further in-depth topics, chapter 1. So thank you, one and all, present here. If you have any queries in understanding the basic parametric definitions, please you can frame your comments in the YouTube channel. Thank you, one and all, once again.